You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everybody. My name is Bob Keane. I'm the editor of the journal Fire Ecology, and this is another edition of Fire Ecology Chats. Today, we have a very exciting topic. I think perhaps the biggest topic in fire today is fuel treatment effectiveness. And we have got some really good guests today, Jeffrey Ott, Francis Kilkenny, and they're going to talk about their paper, Fuel Treatment Effectiveness at the Landscape Scale, a systematic review of simulation studies comparing treatment scenarios in North America. The third author is Terry Jane. So I'd like to introduce Jeff Ott. I wonder if you can tell everybody what your affiliation.
Yes, I'm a research biologist with the Forest Service Rocky Mountain Research Station in Boise.
Francis, could you tell us your affiliation? And then please tell us about your third co-author.
Yeah, so I'm Francis Kilkenny. I'm also with the Rocky Mountain Research Station here in Boise. Our co-author was Terry Jane, who's also with the Rocky Mountain Research Station, and she led this whole project. There were 3 other papers that were produced from a larger group looking at the effects of landscape fire, and Terry was the one who really spearheaded that. So together, I think that set of papers will be really important for managers and folks who are dealing with wildfires.
Jeff, do you want to give us a quick rundown on what the paper is all about?
Yeah, sure. Thanks, Bob. This paper is a review paper, as you mentioned. It fits in with some other papers that were all under the umbrella of one big project. And the focus of this project is to think about fuel treatment effectiveness at the landscape scale. So there's a lot of work being done these days on implementing fuel reduction treatments in areas with wildfire risk. And a big question then is what determines the effectiveness of these treatments at the landscape scale? And by landscape scale, we're meaning an area that's larger than the area that's treated. And that's important because we usually can't treat all the areas. It's not feasible or possible. And so working with that limitation, what is the way to maximize the effectiveness of those treatments? What we did was we did a systematic literature search, found all the papers we could. For our specific paper, we looked at studies that use simulation modeling as the approach for addressing this topic. And that's a very useful approach because this is a topic that's hard to look at empirically through actual experiments. And so we gathered that information and we're basically reviewing the best science available on this topic, specifically through a simulation approach and for ecosystems of North America.
Yeah, I've got to commend you guys. 86 simulation models you worked at. That is a phenomenal amount of work. I was just stunned by the number of models you had. But I do think that one of the topics that our readers will want to know is how exactly did you evaluate effectiveness? And I would like to introduce the second author, Francis Kilkenny. So go ahead, Francis.
Well, thanks, Bob. Thanks for this opportunity. Yeah, so when we talk about effectiveness, I think we really need to think about is what are our goals and objectives when we do fuel treatments? And these fuel treatments can be done in multiple ways. One of them, we think of, okay, do we prevent fires? Do we want to stop those fires? Another way we can think about it is to actually reduce the severity of fires. Fires are a natural part of our systems, but if they're too severe, then they can cause damage that may take quite a long time for ecosystems to recover from. But if we can use fuel treatments to reduce that severity, maybe that recovery time can be lessened, or even if we were to set up fuel treatments in such a way that the fire becomes beneficial. So what we did was we evaluated the effectiveness in several ways once we've defined these objectives. So we looked at reduction in overall wildfire. So that could be reducing fire across the entire landscape, protecting areas from fire actually happening. We also assessed effectiveness by looking at damaging wildfire. So that's getting at that objective of, say, reducing severity. And then lastly, we looked at whether the fire was beneficial or not. And so under these scenarios, when we look at the simulation studies, we try to understand whether different fuel treatment types or different aspects of fuel treatments, how they might affect those different measurements of effectiveness.
Great. That's wonderful. Jeff, I'm just giddy to find out the answer. Are fuel treatments effective? What did you find in this paper?
Looking across all of these different studies out there, in general, they showed that fuel treatments were effective in the ways Francis described. There was some variation, and that was the challenge of this review, trying to understand what made the difference in how effective the treatments were in different cases in these models. And we did the best we could, summarizing across the different papers, extracting information, putting together some figures that show quantitatively what each of these papers showed, and then organizing around certain themes what the major factors were that affected the effectiveness. And we identified 5 major factors related to fuel treatment design. They are the extent of the treatments, the total area treated, the size of individual treatments, the placement of those treatments, prescription, and the timing. And so for each of those specific elements, we looked at what was being shown in these studies. And then also some other factors beyond the treatments themselves, things like the weather conditions. We did find that there was general effectiveness, but looking closer, there's a lot of detail there that we can glean from these studies that have been done.
Yeah, I've got to commend you guys. Distilling down the results from 86 models is not an easy thing. Yet your paper is pretty comprehensive on the things that really affect fuel treatment design. Francis, I wondered, you didn't really include any of the ecology models, and plus it would have doubled or tripled the number of models that you would have had to evaluate. But I imagine that if you included the ecology models, all the results would have been emphasized a little better, and you could have got a better idea of what severity is, correct?
Yeah, I mean, whenever we take on a study like this, you have to set boundaries at some point. And I think this really highlights the fact that, science is an ongoing thing, and we are really framing a certain understanding, and we kind of have to accept that, these models are defining severity in a way that makes sense, and then taking that information and really understanding it in this larger landscape context. But the truth is that these studies are all, very well done. And, in the long run, there are many things we still need to understand. And one of the gaps that we highlighted was understanding those ecosystem effects, all of the interacting things that could happen, right? So different structures of fuels, everything along in the landscape that could affect the way fire moved. We utilized the findings of these other studies and kind of summarized them and tried to see if we could find some lessons. But in the long run, this is an ongoing process of science and really trying to understand all the factors that drive fire.
Great. Jeff, if you want to add anything else, please go ahead.
As Francis was saying, we had to limit our review to certain types of studies. As we sifted through the literature, we found a lot of other things, like you mentioned, that look at other aspects of these questions beyond just the more direct fire effects, which is the focus of this review. So there's definitely more work that can be done in this area, and more opportunity to synthesize what we know.
Great. And Francis, anything you want to add, and any funding assistance?
In terms of funding, so the Joint Fire Sciences Program funded this project. We really thank them for all of their support. This was a long project, so just giving us the leeway that we needed to be able to do what we needed to do was really nice.
I want to thank you both for coming on today and talking about this wonderful paper. I'd like to say, everybody, thanks for coming in with Fire Ecology Chats and listening to us, and stay tuned for the next one. Thank you, Francis, and thank you, Jeff.
Thank you, Bob.
Thanks, Bob.